So, I'll give you a little overview of what I'll talk about here. As an aside, I've given this talk in different forms in the past this year, but it's been kind of different because the audience was a little different. After speaking with the conference organizers and getting some feedback about this talk from people and kind of the things that they wanted to, the messages they wanted, the sort of things that they were interested in hearing, I decided to change the way that I do this. So if you happen to watch a version of this talk at Microsoft Build or something like that, then you're going to see something different today, even though I guess some of the basics are still going to be there. I think I'll start with a little overview of F#, the language, and ecosystem, tooling, like all that sort of stuff, so you get a decent, holistic idea of what F# is all about today. Then I'll talk a little bit about F# usage kind of across the world after having spoken with multiple customers, just open source developers, all that sort of stuff. And I learned a lot about how people are using F# not only in their day-to-day work, but even including side projects. And I wanted to share some of that. I'll talk a little bit about how Microsoft thinks about F# strategically, so that this is really getting into the nitty-gritty of kind of why F#. That's hopefully a convincing story to tell. And then I want to talk a little bit about how F# stacks up with other functional programming languages. Hopefully that part is not too controversial. I tend to think that I'm objective in evaluating different languages because I like languages as a whole. So if something is rather controversial, well, hopefully it doesn't get too many people angry. Basic overview of F#. Let's talk about some facts, because facts are great. I like facts. So it's functional programming for .NET. You write functional programming code for .NET in F#. That's this. I've thought about kind of how I want to describe F# in the past. So it's like this functional first language. It's got object, blah blah blah, and like nothing really fit other than it's functional programming for .NET. There are other ways that you can do functional programming for .NET. You can even use C#, but you're probably not going to have as good of a time as if you just went with F# anyway. So that's just really the most important bit. It also has object-oriented capabilities. So you can write F# code using objects to interoperate with the rest of .NET, to interoperate with another library that's very object-oriented heavy. And you can sort of say, OK, well, I'm going to use OO to deal with what I need to deal with, and then call into a very functional kernel, if you will, in the rest of my F# code, and kind of be sort of hybrid functional in OO, but kind of it's unlike other languages where there's like a very distinct separation between the OO and the functional. We sort of try to blend things a little bit and take the bits of OO that actually are functional and say, no, this is part of functional programming, and this is something that you can embrace. Okay, F# is part of the .NET Core SDK. That is to say, if you have .NET Core installed on your machine today, you have F# already on your machine today. There's no special button you need to click somewhere. There's no special download. You just already have it. If you don't have .NET Core on your machine, I suggest you go ahead and get it, because it's pretty cool. It didn't just accidentally fall in there like, oh, whoops, there's F# in there. Like it's a very deliberate decision. I'm going to talk about that a little bit more as the talk goes on. F# runs everywhere. Just by virtue of being on .NET. I mean, you can do Windows apps in .NET Framework, kind of as existing F# developers have likely done for quite a long time already. Xamarin Forms, Xamarin iOS, and Xamarin Android, you can just do it. I mean, I don't really know how else to say it other than there's templates, there's tooling support, it all works. You can just do it, it's fun. And there's .NET Core and ASP.NET Core support for F#, and there are multiple libraries that sit on top of ASP.NET Core depending on the flavor of web server programming that you want to do. And I think that's rather important because very recently ASP.NET Core broke the top 10 in Tech and Power benchmarks, and the team is very focused on making it a highly performant web stack. And so as a result of just being on ASP.NET Core and being part of .NET Core, F#, it's a language that you can use to write highly performant web servers. That's just a thing that you can do now, which is fantastic. So I want to talk a little bit about what I tried to reduce down into what I think are the most key aspects of what F# programming is all about. Because there's a bunch of different features, there's a bunch of different things that you can do with the language, and some are interesting for some people, some are not that interesting for some people. But there's actually really only two things that everybody does with F#. And the first one is you use types to model data. If it's kind of an obvious statement, right? I mean, you do that in object-oriented programming as well, but it's a little different. I mean, if I wanted to very poorly model the domain of a withdrawal from a bank account, I could create a type called a successful withdrawal that is just an aggregate of, an amount, in this case a decimal, and whatever the balance was. And what's interesting is this isn't like an object in C# or Java where I then need to think about, what other OO-isms do I have to put on here so I can do things like default equality or be able to compare things really easily, or oftentimes, especially in like a distributed scenario, you want things to be immutable, and like it's kind of nice to have things to be immutable by default, which you can't really do in some of these object-oriented programming languages, which is the default here, right? This is a record type where it's immutable, it's default equatable, and it's default comparable. And it just has some values inside of it. And there's honestly not much more to it, which is what I really, really love about this, because it's just such a straightforward mapping between something that could happen and how you're going to represent it in a way. And then you could have a failed withdrawal that could just have a bit more in there. In this case, an amount balance, and if I potentially overdrafted. And so I guess in this case, I set my bank account up such that if I were to overdraft, then it would fail. There's lots of different ways you could tweak this. I'm not a domain modeler. And then there's this other type, which is called a discriminated union type, where I can say, okay, well, I'm going to try to withdraw something, and it could come back a number of different ways, right? It could succeed, and then I have my withdrawal, cool, that's nice. But I could not have enough money, in which case that's this failed withdrawal that I've called here. There could be multiple types of failures that can occur, right? Like if I withdrew with a card, maybe my card's expired, so it's obviously not going to withdraw. For a financial system like this, you're probably going to have 20, maybe even 30 different cases of things that can occur. But kind of what I really like about this is how it's just one line maps to one case. And it's a very succinct way of sort of dealing with the fact that information it could be coming in multiple forms, and you want to have a way to represent that in a very type-safe way. If you were to try to do this in C# or Java, you'd be writing a lot of code. And that code would probably be very error-prone. It probably wouldn't be the nicest to write, because it's just this sort of modeling of saying, okay, I want to have some aggregate data, and then I want to have data that could represent multiple different forms. Is just not something that those type systems were set up to do. As it turns out, just in standard everyday programming, these are common problems that people have, and so this is why it's so ubiquitous throughout all F# programming. And so this is the first key element of F# programming. The second one is just some functions that act on the data, right? So in this case, if I want to handle a withdrawal, I want to say, okay, I want to withdraw this amount of money, do the withdrawal. It gives me a result that I then need to deal with, right? In many other languages, you would have to you would have to know to put the if statement everywhere. And if you have a junior programmer who may not necessarily be aware of the complexity of a given domain because they just haven't been there long enough or something like that, they may miss an if statement somewhere. And there's nothing in the language that would tell them, hey, you didn't account for all possible cases here. This is another critical thing. This is pattern matching. And if you're familiar with C# pattern matching, just imagine that it has more functionality and that it's better. And that's basically what this is doing. And yes, F# has inspired C# pattern matching so far, so because we've had it before. So in this case, the gist of what's going on here is just saying, okay, well, there's a result, and I want to act on that data based on the shape of that data, right? So I took my data, I modeled it with types, like a really powerful type system, and then I go in and I say, all right, now I'm going to dispatch functionality based on the way that the data is actually formed. This is, if you're coming from a dynamically typed language, your code might actually look fairly similar to this. Like in JavaScript, you can just say, oh, well, it's just this object, it's got this stuff on there. But in that sort of land, you don't have the type safety. So something could go wrong at some point during, who knows when, and then all of a sudden your code won't work anymore. Well, in this case, because it's strongly typed, you actually get the compile time stuff. And so kind of the whole model with types, records, and discriminated unions, and then add functions that act on that data that's represented as types, and pattern matching on that data makes up almost every single, if not every single, like actual fully formed F# program out there. From the biggest systems to just the smallest of side projects, like this is just what you do. And I was thinking about if I should go into other different interesting techniques that you could apply here, like functional composition or higher order functions or something like that. But honestly, that's not even necessary for writing good F# code. Really, you just take some types that you use to model data, and that itself is an art form, I guess. And then you just act on it with functions, and it's super easy in F#. And you can go a really, really long way just with these two core concepts. And I want people who are new to F# to sort of feel that that's really all that they need to know to get started. And you can build your own DSL with this, for example. So it's pretty powerful. But that's not the only thing that F# is about. I mentioned the OO stuff, and the reality is that F# lives on .NET. .NET was built with C#. C# is an object-oriented programming language. .NET has object-oriented constructs inside of it, and you have to interact with that in some way. But more to the point, it's not even just dealing with that reality that explains why we have object-oriented capabilities. But sometimes you may actually want to do something with objects that are not easily represented in a record or discriminated union, right? So, you can put attributes on stuff. That's fairly straightforward. You can use the sealed attribute if you use that in C#. It does exactly what you think it does. Compiled name does probably exactly what you think it does. It just gives it a name, so in the assembly, that's what it's actually called. And then you have another type declaration, but in this case, it's a bit more complicated because maybe you want to do something that is a bit more intricate in nature. This is where objects can really come in handy. In this case, this is actually taken from the F# core library source itself. We have a set type, and it's sealed. It has a compiled name, and then we have a type parameter that we have another attribute on, and then we refine that type parameter by saying, yes, well, it takes in, you can have a set of T when T is comparable, okay? This is, I think, what people would normally associate with being object-oriented, but it's objects. It's more just object programming so much as object-oriented, because everything that I'm showing so far is actually really functional, right? So there's a constructor, new, given some elements that is a sequence of type T, produce a set of type T, right? Where T is that refined, T that's comparable there. That's entirely functional. Right? You can have a method called add. These are type signatures, by the way. A method called add that, given a value, which is of type T, produce a set of type T, which is basically saying, I have a set, I'm going to add a value to it. Well, that's actually a different set, right? It's a set that contains another value. So it is conceptually a different thing. Now, under the covers, there's like this is an immutable data structure that's implemented with, trees and stuff to kind of swap out nodes and things like that, so it's efficient. But this is the way that you reason about it, because it's not add an element to a thing and thus change the thing in place. It's adding an element to a thing produces a new thing, and you can accomplish this with object-oriented constructs, but still stay completely functional. There's a whole bunch more methods, but I didn't bother showing them. You can do interface implementation like this. And interfaces are, again, actually a very functional concept. This is just saying, here's a contract where, I have this functionality. And you say, I'm going to implement this functionality. And then other callers can just deal with, interfaces in that sort of contract-based way. This is usually the way that you communicate across assembly boundaries in .NET anyways, or at least, I guess, the way that you're supposed to do it. And that's just that's the viewpoint that we take with F# as well. Except you can communicate with other F# components this way too. Like, this isn't just for interoperating with some C# code or, some API that requires an interface or something like that. In this case, set apparently has 5 interface implementations, which is pretty cool. So you can view it like that. And we have lovely overrides because we want to change the way that default equality works in this case. Another thing that's interesting about classes, because this is just a class, right? The implementation is elided, but you can sort of understand kind of what the general structure is just by looking at the signature. They're a bit different in that, so they cannot be assigned null by default. I need to actually decorate it with an attribute called allow null literal. So this whole nullability sort of thing is just already baked in. they're also, when you bind it to a value, you say, let x equals, construct a new set or something like that. X is immutable by default. You cannot change X itself. You have to actually declare it as mutable if you want to do that. Now, because it is a class, you can have mutable values inside of the class that you could mutate in place and so forth. But that's like an opt-in sort of thing, right? We want you to sort of opt into things like mutability and changing things in place, which could potentially complicate a program. But we want to extract all the good bits of object programming and say, this is functional too. It's just got maybe some different syntax than other languages would, consider something like that. So you use OO when it makes sense in F#. And like you don't do it like in contrast to modeling types with data and acting on that data with functions. You do it you do it when it makes sense. Sometimes you need to do something that's a bit more complicated, but you can still stay functional. And I think this is kind of rounding out sort of the spirit of F# programming. And guidance for this is entirely documented. So this is a cute little short URL, aka.ms/F# style guide. This is an official style guide that sort of documents some of this stuff and much, much more detailed stuff too. But kind of the whole point of that is if you're learning F# and you're working with a construct and then you say, oh, well, am I using this construct in a good way? Basically, this guide is supposed to answer that question for you. And so something that you can bookmark and refer to as you kind of go on your functional programming journey. Something that I'm particularly proud about with this is built in collaboration with customers and other open source contributors who have large code bases in F#, who have had years of experience dealing with lots of different features, and then basically being able to say, hey, guess what? We used this feature and it totally sucked. We should totally not do this at all. And that was based off of F# in the large, solving hard problems. It's also an evolving set of documents, so it's entirely open source. We welcome any contributions and additional questions to it. And if you read it, if you're an experienced F# developer, you read it and you say, I hate everything about this. This says all the wrong stuff. Well, because it's open source, you can actually, give us that feedback, and we can have a discussion about that sort of stuff. And so I would definitely watch this if you're new to F# because it's going to be continually evolving and more things are going to be added. Right? So another interesting bit about F# is that it has truly ubiquitous tooling. And I don't mean that in the sense of every tooling vendor or open source contributor, creates their own version of the compiler that mimics F# semantics, as best as they can. The F# compiler itself, very similar to Roslyn actually, is a compiler that has APIs. And those APIs are part of what's called the F# compiler service, and that's what's used by editors everywhere, including Visual Studio. Okay? So Visual Studio's had F# support for quite a while, but that's not the only one that you have to, it's not the only way for you to get F# programming into your daily work. Visual Studio for Mac also installs F# by default. Visual Studio Code and Ionide so Ionide it's a community plugin, but it's like the official F# plugin for writing F# code in Visual Studio Code. If you're the kind of person who just prefers a lighter weight text editor, but all of the features of an IDE without the big installation size of an IDE, you can get this. It's really, really cool. It's a community technical initiative that just really took off and has flourished, I think, into something that thousands of people love using every single day. Okay. There's .NET CLI support for F# because that comes in the .NET Core SDK. If you're in the business of making builds work on a build server, well, there you go. That's how you do it. It's real easy. JetBrains Rider, they're actually here today. Recommend checking them out. They install F# by default as well. So if you want to see what that's all about, you can do that too. And the thing that's great about each of these editors, including Vim, is kind of, as I said, they're using the same compiler and the same compiler APIs. So this isn't, as I said, one person going in and implementing some subset of F# semantics and building tools around it. This is actually the same core component, and this is, I think, unique across all functional programming languages. I think every other language for tooling vendors and open source contributors, they sort of build their own compiler effectively, and it's sometimes not the same compiler as what gets bundled up with their build tools, and that can that can lead to some confusion. That's just not a thing in F#, which is phenomenal. So. Another really cool thing about F#, it runs on the web, and I don't mean like on a web server, I mean literally on the web. There's this amazing project out there called Fable. If you value GitHub stars like you value currency, then Fable is just as important as F# itself because it has like the same amount of stars. It's pretty cool. It's an F# to JavaScript compiler where it just takes the F# syntax tree and then it converts it into a Babel syntax tree. So if you're familiar at all with Babel, it's a really good way to write modern JavaScript and have it run in way more browsers. This is what it does, and then it also supports JS native interop. So like if you need to interoperate with a thing that you know is literally there in JavaScript, like you can do that. It's actually conceptually somewhat similar to like pinvoke and stuff. It's fantastic. This is an entirely open source initiative, and the goal was to create a viable JavaScript alternative, and they have accomplished that goal, which is absolutely great. You can use the entire NPM ecosystem for this. So you can write your F# code to literally replace JavaScript. You can include any library that you want. You can consume TypeScript definition files because maybe one of your coworkers is a TypeScript fan. You can produce TypeScript definition files so you can give them stuff, right? You can use React and Redux tools, and like you can do the whole message-based UI stuff, and then do time travel debugging and source maps with Chrome. Like all of that is supported. It literally shows F# in the source map. It's incredible. I didn't mention it here, but there's hot module reloading too, so you can just have a piece of F# code that you change, and then when you save it, it doesn't rebuild the entire DOM. It just builds that little piece that you actually changed. It's incredible. There's another way that you can do F# on the web called Web Sharper, which has been around for a lot longer, and it has slightly different goals. Its goal is to be a full-stack functional reactive programming framework for F# and also C# that is basically built on .NET Core. I think their goals have changed over time because I think they're on Web Sharper version 4. But it runs in the browser as well, and you can use that to run on React Native and have it run on the phones and things like that. And it's a commercial product with commercial support. So if that's the sort of thing that you're interested in, I definitely recommend checking it out. Fable.io, I didn't mention this, it has a REPL. So you can actually play around with it in the browser. It's one of the coolest things ever. So I'm really excited about it. F# also runs in Azure. Or any cloud that's not Azure, I guess. But yeah, it runs in Azure, yeah. It's fully supported in Azure Functions, which is a big deal because that's something that we really care a lot about for Azure moving forward. It's kind of been there almost really from the get-go. The portal-based, script-based stuff, it's been there for quite a long time. It's still there. It works just great. You can do compiled library-style stuff with V2 Azure Functions. There's a little bit of work that we have to do to light up the templates in Visual Studio that's on our roadmap. It's just not there yet. But you can use the .NET CLI to create one of these things, and you can go ahead and publish it to Azure. It all works. There's also a new functions programming model called durable functions. It's very much in pre-release right now, but it's going to definitely transform the service. And there's already a community effort to build an F# programming model around that when you're using F# for it. It uses a feature of F# called computation expressions, and it's beautiful, beautiful programming model. So that's something to look out for. Azure Notebooks is another thing that's powered by an IF# kernel. So if you're familiar with IPython kernels, or I think there's an iScala kernel, IJS kernel, something like that. This is interactive. It's just an interactive programming environment for the browser using Jupyter Notebooks. And it's a really great tool for beginners. We actually have a template that you can do, which is an introduction to F#. So if you don't have anything installed on your machine except for a browser, you can use that today. And then you can share the Jupyter Notebooks that you produce with other people. So it uses just like a Git-based model, and so you can fork and clone different things and so forth. And you can do that all in F#, which is really cool. And then all other services where .NET runs, F# runs as well, and it's fully supported because it's a .NET language, right? .NET is a first-class citizen in Azure, therefore F# is a first-class citizen in Azure. So this is really important because Azure is quite important for the future of Microsoft, so that makes me happy. So that was an overview of kind of how I'm framing up F#, like modern F# today, the way it exists. I want to talk a little bit about where it's used, because one thing that I hear from a lot of people is, oh, but what would I use F# for? Who uses F#? What do they do with it? Like that sort of thing. Well, I'll talk first about how it's used in industry, and then I'll talk about how it's used within Microsoft. So in industry, one of our largest customers is Jet.com. You can read their tech blog. They have a whole bunch of F# stuff on there. It's pretty cool. They have hundreds of F# engineers building a state-of-the-art e-commerce system, like literally hundreds. And they're like taking over this building that they're in. When they used to be a startup, now they're just like booting people out of the building because they're growing so fast. And they have a massive F# code base, implementing all sorts of really cool stuff. And they attribute a lot of their success from growing from just a tiny startup to a really big growing business to their use of F# and doing literally what I showed, just modeling complex data with types and then acting on that with functions. I mean, they use some other advanced features and stuff too, but fundamentally that's all that they're doing. And they were able to see a lot of success with that. Genetec is another company that's been using F# for quite a long time. They're a large IoT solutions company. So I'm not sure if they have F# running on the IoT devices, but they do have it on like their management services that sort of deal with all the different types of devices that could go in, the different protocols that are coming over the wire and stuff like that. Well, again, they sort of model a lot of that data with types in F#, and they're able to implement things for the different IoT devices that they have very, very rapidly. And it's been quite a maintainable thing for them. So NRK, if you're familiar with that, certainly here in the audience, largest media organization in Norway. They have multiple teams using F#. I just visited with them yesterday, and it was a great time. They're growing. They're hiring. Well, at least they've certainly hired new F# programmers, and they've seen a lot of success with using F# to manage some of their TV services, I believe, and radio services as well. And then there's many smaller organizations worldwide. There's also some bigger ones, like some banks that I don't know if they're okay with being mentioned that they use the technology, so I'm just not going to mention them. But it's used in the finance industry a lot. It's used in financial modeling, statistical modeling, data science, just mom and pop web apps, like just everything from what you would consider complex systems to just kind of everyday create, read, update, delete systems. F# is used from organizations large and small. Speaking of large organizations, it's also used at Microsoft. And it's used in a few places. So F# came from Microsoft Research. That's where it was born, and thus it has quite a bit of usage there. They have a lot of different teams using it for different research projects, and then we also have multiple data science teams at Microsoft that also use F# for some of their data science efforts, like within Office, Windows, Azure, and so forth. It's actually a personal quest of mine over the next year or so is to reach out to other data science teams and sort of see if F# would make sense for some of the problems that they encounter. We have a product called Microsoft Security Risk Detection. It used to be called Project Springfield. This used to be an MSR project, but it's grown into a full product. It's basically they do fuzz detection as a service. Yeah, fuzzing as a service. And so you just basically upload parts of your application. You say, I want you to beat this thing to death and tell me where every single possible issue could arise from a security perspective, and then they do that. The fuzzer, I believe, is written in C++, but the actual product is written in F#. And they were very deliberate about that. They started from the beginning. They said, this is going to be a service running in Azure. This is a distributed system. Because it's a distributed system, we like to have less surprises. So immutable by default is a good way to have less surprises about your data. And they just kind of went from there, and they've been very successful in onboarding new engineers who knew nothing about F#, and just growing their product from like a research thing into a fully fledged product that we now sell people in Azure, which is pretty cool. There's the Notes and Tasks team at Microsoft. So some of the products that they own are OneNote and Windows Sticky Notes. They're an interesting group. They're a very polyglot group. So they use lots of different languages. But a lot of them in particular are fans of functional programming. And they needed to do some stuff with .NET. And they're like, hey, well, we want to do FP on .NET, so let's just use F#. And specifically, the team that is using it, and also hiring, by the way, is I think it's called the Notes Fabric team, or the Notes and Tasks Fabric. Basically, what they do is they're sort of like a sync layer between multiple different applications, like OneNote, Wendy's Sticky Notes, Microsoft To Do, Wunderlist, various to-do items that you can have on different versions of Exchange, going back to like 2008 or something like that. There's a lot of complex problems in syncing information across all these different data formats and these different applications running in different environments. And they chose F# and, well, functional programming specifically, deliberately to do that. And they wanted to use F# and they wanted to do it on .NET. And they've been quite successful with it to the point where they're hiring. So that's pretty cool. There's a group within Azure that does anomaly detection. So they're kind of a data science team, but they also have a little web service that they built. I guess it's more of an internal tool more than anything else, but it's just they wanted to throw up a quick web service to sort of report information about the different models that they run on Azure usage, so that when they see a spike, they can determine with some likelihood if it was actual usage from a customer or if it was an anomaly, and not make sure not to bill this person for something that they didn't do. I would argue that's a rather important part of the Microsoft business. That is, F# is highly involved in this. So it's something you could tell your boss, I guess. And lastly, the thing that I work on, my pride and joy, the F# compiler and the tools for Visual Studio are also implemented entirely in F#, except for the little C# v6 project, I think, that we have. And we have like some template stuff in Visual Basic, but it's really all F#. So that's, at least as far as I know, what people do primarily with F# within Microsoft. There are some personal projects, there are some smaller tools and things like that that various teams use. I guess they just weren't big enough or noteworthy to call out here. So, speaking of Microsoft and F#, I said that I would give a little bit of a view into sort of how we think about F# strategically. Well, that's this part right here. Hang on. As a side note, when I went and built and I drank some water, I think it's like minute 35 or something like that, there was a really just like glug, 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 glug here, sound that you can hear. I hope that does not happen again. But, oh well. So we have a very basic viewpoint for F#. I mean, this slide could honestly just be this single bullet point. The way that we think about it is that it ought to be, and should forever be the most productive functional programming language on the market. What productive means is kind of up to you. Some people care about tools. Some people care about the speed of the compiler. Some people care about the speed of the runtime. Some people care about the different abstractions that are available. Some people care about if they're able to hire for it. Like, productive can mean anything really, but it's intentionally general and perhaps vague on purpose, because it's really about the sum of the parts, right? F# is not just about having a particular thing in its type system. It's not just about having some tools that are really good. It's not just about having a compiler that's faster than Scala's compiler. Like, that's right, but all of these things, there may be one area where one particular language or environment does something better, and there may be an area where we do something the best. Like and that can change over time, right? But the way that we look at it is, well, if you aggregate everything that people typically think of being productive with a programming language, we want that aggregate to feel like it's the greatest in F#. And if it's not, then we want to work to make that true. Okay, we think it's integral. It's an integral part of .NET's future. This is, well, kind of as I said, it wasn't by accident that F# is in the .NET SDK. It didn't just, skip over and just hop in. Like it's part of .NET's future. We're trying to expand the reach of .NET beyond the realm of Windows, and F# is a part of that, simply, right? And that's just how we view it. We think it's a great choice for cloud programming. Kind of as I mentioned, when you're doing things with distributed systems, you tend to not like surprises. And you get more surprises when your data is mutable by default, or at least the programming language in which you model your data is mutable by default, right? We are immutable by default, so you get less surprises, and that's pretty good in a distributed environment where things are so hairy anyways. Okay, we view F# as innovating in language design and tools, right? And this isn't to say that C# is not. We view C# as doing this as well, but F# does it in a different way. I mentioned computation expressions earlier. It's this beautiful way to represent what a Haskell programmer may call monadic composition or something like that. But really what it's all about is there can be a kind of domain-level context in which code needs to execute. And that context may not be as straightforward as just a single-threaded, straightforward thing. And like, for example, in the F# tools for Visual Studio, well, actually, sorry, not for Visual Studio, in the F# compiler service, there's a notion of something being cancelable, because you can have a potentially long-running operation. And you may want to queue up another operation that needs to run, and that might be more important, like, coloring up a document that you right-click opened while another operation was happening. Well, you don't want to have that document fail to open and show colors and stuff while a long-running thing is going on. So we want to be able to represent the notion of a potentially long-running computation that can be canceled at some point in time and superseded by another one. The way that that's implemented is with a language feature that allows you to do so in a type-safe and really beautiful and maintainable way. And then on the tooling side of that, with the forthcoming F# 4.5 release that's going to be coming out later this summer or perhaps in the fall, we'll see, we're doing some work to tool this sort of stuff a little bit better, specifically with the asynchronous computation expression that we have. And produce better stack traces from this sort of stuff, because there's language design and then there's tooling that surrounds a particular feature or set of features. And we view that as part of innovation as well, because C# went and did an amazing set of things with async stack traces. But they have a totally different model for asynchronous computation than we do, even though fundamentally it's doing the same thing. It's a thing called a hot task model, whereas we have a cold task model. Well, the question of how do you tool something like a cold task model is something that we innovate in. And we feel that this is really important, not just for the language F#, but for the .NET ecosystem as well. It's an area where this stuff can happen. We also view it as a place to innovate in mobile development. There's been a bit of a recent surge in wanting to do functional reactive programming, or this thing called model view update for phone UIs. And people can use React Native for that today. Well, we're doing some work to build a model like that for Xamarin-based development, so that if you want to do that for mobile development, we're going to have that available in F# too. And lastly, and perhaps one of the most important things, is we have an innovative community, right? They start incredible technical initiatives. Not all of them succeed, but that's fine. I mean, for innovation, you need to experiment, and you need to see what's going on. But some of those really stick, like Inide. An IDE without the baggage of an IDE inside of Visual Studio Code. Incredible. Fable, like being able to run F# coherently in a browser and be able to use all the JavaScript-based tools. This is something that they do, and they're very driven individuals in the community, and it's infectious. People who come in and they're new, they may not have had a history of contributing to open source, and then they get excited about that because everybody else in the F# community is excited about that. And then people do things like in the version that's going to be coming up, F# 4.5, one of the new language features was implemented entirely by a brand new community member. He hadn't been, he actually came in later this year. Sorry, actually, earlier this year. And he created an issue on GitHub for our language suggestions repository, which is open source. And then we all sort of said, yeah, this is a good idea. He created the RFC for the actual spec of what this is going to be. And then he wrote the feature in the compiler, and then he collaborated with us and with other members in the community to figure out what the best error message is and things like that. And then it got merged. And this is a brand new person came in, and there's stories like this all over the place in the F# community. And they're keen on collaborating with Microsoft too. They don't feel like they're this isolated group of people who have to do stuff despite some corporation taking the thing that they love in some other direction. They want to see not only other people in the community succeed, but they want to see Microsoft succeed as well. And this is really important. And they're also very happy to let us know when we do something poorly, which is extremely valuable, actually. That smiley face is not a sarcastic one. It's oftentimes you can get caught up in your bubble trying to build something, and you don't really see the forest for the trees. And sometimes it just takes an active community member who really knows what they're doing to tell you to stop. And the F# community are willing to do this sort of thing, which is incredibly valuable. So we have a few core tenets about the language, I guess is how I'm calling it. This is somewhat similar to how we view F# there, but I guess a slightly refined version of that, right? F# is a part of .NET, and F# evolves as .NET evolves, right? So that doesn't mean that .NET, grabs F# and just drags it along screaming or something like that. It's a collaborative effort where F# innovates in a certain way. That feeds into .NET. .NET moves in that direction, particularly as far as the community is concerned. The F# has always had an incredible community, and this is something that .NET as a whole has always sought. And it's, within .NET, there is actually an example of how to do things, which is pretty great. F# runs well on Azure, is one of our core tenants. And that means if there's an issue with F# running well on Azure today, it's something that's going to be prioritized and fixed because we want it to run well on Azure. F# innovates in many ways, like, not just in language features, but also in how you tool those language features. F# as a whole, not just the Microsoft employees working on F#, but F# also innovates in the community space, I think, right? F# evolves steadily and prioritizes stability and predictability. I'm going to talk about this a little bit more shortly, but basically what this means is that as we evolve the F# language by, adding new features or something like that, people in the community should not feel surprised at a new feature coming along or something like that. It should be very traceable, and basically if they're surprised by something coming along, it should be because they weren't paying attention, not because we live in some ivory tower and then threw something over the wall and then they had to catch it and go, oh geez, I guess we're gonna have to do something with this. Like that's just not a thing in F#, and that's something that is a core tenet that we want to continue, okay? And another core tenet, F# has ubiquitous and featureful tools. You can use all of the greatness with F# IDE tooling in your environment of choice. You don't have to use Visual Studio. You don't have to use Windows. You can do it where you want to. Okay? And then F# is developed openly and in collaboration with the community. The last two versions of the language, so the forthcoming one, 4.5, and then the one that we're on right now, the current version of F# has multiple features that were done by community members. And then other features, even though they were implemented by Microsoft employees, had a lot of work, not just in GitHub comments, but in actual, when it was a language suggestion, and just discussion and hashing out the various problems that could arise with using something. What are the trade-offs? What are the use cases? How is this potentially useful? Helping us draft RFCs and noticing, hey, this thing that you're designing, maybe you should say it a little differently or something like that. That's the way it's all done, and this is something that we wish to continue still. So now comes the hopefully not too crazy part where I compare F# to other functional programming languages. Because you're in the FP track. This is not the F# track, despite the fact that there's a whole bunch of F# talks. Right, but there are other functional languages out there. And despite the fact that I want you to use F#, I don't want you to only use F#. I want you to check out other languages too and evaluate them based on what you prioritize. But I'm going to talk a little bit about some pros and cons with three of the other popular functional programming languages. And hopefully they make sense and hopefully they resonate. And if not, well, you can tell me afterwards. So Haskell, this is like the granddaddy of functional programming languages. This is the FP language if you want to bend your mind for sure. Let's talk about some cons of F# versus Haskell. So first of all, we have less language features. Some people may say that's a feature, other people won't. It just kind of depends on who you are, but we do have strictly less language features. Right? We lack many of the higher order abstractions that are possible in Haskell with different language, especially with different language extensions. Like, I don't know if anybody's played around with liquid Haskell at all, but that stuff blows your mind, right? And there's not even a concept of like a language extension inside of F#. There's no way for one person in research to sort of say, oh, I'm going to just really go to town on this, aspect of category theory and then incorporate it into the language and then have you be able to opt into it on an ad hoc basis, right? That's something that you can do in Haskell that you cannot do in F# today. And if that's something that you value and something that you want, then you may find yourself not enjoying F# as much as Haskell. All right? And then lastly, and I mean this earnestly, and I think it's not something that we can particularly overcome, I think Haskell is strictly better when it comes to just blowing your mind. Like if you want to just blow up your brain and then scrape your brain off the walls afterwards because this thing totally changed the way you thought about programming, Haskell is probably the best language to do so. You can absolutely do this in F# too, but if you want to go way further, you should go with Haskell for sure. All right, and if that's, I mean, for some people, that is the goal of learning FP, is you want to blow your mind a little bit, and Haskell is the best way to do that. But there are some advantages to using F# over Haskell. Number one, we have consistent idioms and code style. So if you look up how to solve a particular problem in Haskell, you're going to find a tremendous amount of answers, which are probably all great ways to solve it, but that doesn't necessarily mean those ways are going to help you out, because they may depend on a particular concept that will require a week's worth of learning for you to be able to even understand how the code works. Or maybe the thing that they showed won't work for you anymore because Haskell does binary, and they do breaking changes, sometimes between minor versions of the compiler. And this is something that we just don't do in F#. Or rather, if we do, it's considered a bug or an accident, and it gets fixed. We don't break things intentionally. And so the intention is that 5 years down the road, code that you've written today should still be able to work with a future version of the language and a future version of the tools. This is not something that's true in the Haskell world. And it's something that if you want to go that route, you need to be prepared for. We have commercial tooling and support from Microsoft and JetBrains, period. Right? There's commercial tooling and support from 2 different companies. And it runs on officially supported platforms. Right? There's an official SDK for .NET for Azure, an official SDK for AWS. Right? That's F# runs on .NET. There you go. Right? There are no official SDKs for Haskell on any of these platforms or things like that. Or maybe there's some community-driven thing, but it's not supported by a company that actually owns that platform. If that's something that matters to you, well, that's an advantage of F#. F# versus Clojure. This is great. I actually did my college project in Clojure, so I really love Clojure as a language. I encourage you to check it out, despite what I say. There are some cons. So this is where Clojure does better than F#. I think in F#, there's a lot more ceremony for working with data. Clojure is it's a dynamic language, so it's incredible for just slurping up data of any shape and turning it into a map. Like the Clojure map type is amazing. And if you want to do a similar thing in F#, like as I showed earlier, you have to do these different type declarations, and there's different types of types, and maybe you have to blend a little bit of OO with it if you want to express it quite succinctly. That's a lot more overhead than just doing something in Clojure. And if your primary job is to do something like that, then maybe Clojure is a bit more appropriate. It's hard to say. This is something you're going to have to try out on your own and evaluate. F# also has no macro support the way that Clojure does. So, I mean, if you've ever experimented with macros in a language, they're pretty cool. And they can allow you to express things very succinctly. And, well, on the other hand, sometimes they can be a little opaque, and especially new people who aren't familiar with macros usually have no idea what they're doing. But if that's something that you value, then this is a distinct advantage that Clojure has over F#. We have nothing like Clojure.spec. It's a relatively new thing that came out. It's like venturing into the realm of refinement types, like you get with Idris and F*, which are other interesting functional programming languages. But it's in a dynamic setting, and it's basically saying, well, you can write this specification of the way the incoming data for something should look and properties of that data. And then you can just write code that wires that up, and it all basically just works. And then you can like customize errors and stuff if the data doesn't look the way that you specified it to. It's pretty great, and we don't have something like that. So that's something to keep in mind. But there are some pros to F# over Clojure. So static nominal types are pretty easy to write maintainable code with. I think sometimes, at least in the functional programming community, people can get a little overzealous about how nominal type, there's all these amazing type stuff, but like fundamentally, just having static types and just having a nominal type system takes you a really long way, and it's really easy to modify code because it's just a really direct one-to-one mapping between I say I am this thing, I am defined as not this thing, therefore it is a compiler error, period, right? If I say that I am a thing and then it's defined as this thing, that's just what it is. It's a very straightforward thing. It's a rather underrated feature, if you will. And this is, Clojure is a dynamic language, so it doesn't have static typing and doesn't have, this nominal type system that you can use. F# has comprehensible error messages. Anybody who's played with Clojure for anything serious knows that the error messages are basically just dumps of a stack trace. They're no fun. It's something the Clojure community has been complaining about for a long time. It hasn't really been addressed that well. it's good error messages are really hard, but it's something that we get from the type system that we're in, and then also something that the F# community in particular has really sought to improve over the past year and a half or so, 2 years, that sort of thing. And having error messages where not only does it very succinctly and accurately tell you what the problem is, but it can sometimes also offer suggestions based on information that the compiler holds at that time. Like if you're trying to do something with an enumeration where you've defined a certain number of cases, an F# enum, and you only account for one of those cases, well, you can get a warning that will tell you, hey, you're not accounting for all the cases. By the way, here's an example of some of the cases that you're not accounting for. That's just something that we have in our error message, which it's pretty important. Another thing is that evolution of the F# language is entirely in the open. If you follow some of the folks in the Clojure community, there can be sometimes a sense that it's a bit of an ivory tower sort of situation in terms of what happens in the language, and then stuff gets thrown over the wall. It's up to you to interpret kind of the level of truth to that, but I mean, it's something that you can read about pretty easily. This is just not something that we do in F#. One of our fundamental tenets is entirely open collaboration with the community, from suggestions to what the language should be, to RFCs specifying exactly what's going to be implemented, to the actual implementation, and feedback loops all across that whole thing. That's just the way that F# evolves. And finally, F# versus Scala. So this is actually a bit of a blending of the first two, really. So some of the cons, we have less language features than Scala. Scala has a whole bunch of language features. Sometimes, they're not necessarily what people would enjoy the most, but they exist. There's lots of features there. More specifically, this is a more specific version of the lacking higher ordered things, but there's no higher kind of types. This is something that in F#, and this is something that a lot of Scala developers view as essential to being able to abstract stuff. There are ways that you can abstract where you can basically abstract the same way in F# that you don't have to even simulate higher kind of types, but you can get that same level of abstraction just perhaps through a different vehicle. And this is something that sometimes people may not feel comfortable with because they may want to use a higher kind of type system to represent certain abstractions. And if that's not possible, or the way to do it is different than what they're used to, that could potentially be seen as a con. That's just something we have there. Also, really, honestly, an important one, there's no native Akka or Spark support. Now, there is Akka.net, and there are alternatives to Spark on .NET, and those will get you very far. Akka.net is a fantastic open source project. I really recommend trying it out. But at the end of the day, Akka and Spark are these two really big, very well-used frameworks that were built in Scala by consulting companies in the Scala community. And that's just where it originated. And if that's something that your business needs to do, or if they say these are the frameworks that we want to use, Scala is probably the best choice for doing that. But well, there's some pros. Similar to the Haskell thing, we have consistent idioms and code style. There's at least from my vantage point, there's quite a split in the Scala community between the super functional group, the people who love category theory and they want to lift some of the amazing stuff out there into their programming, and they want to model their systems as mathematically as possible. And I mean that in a very good way, right? And then there's another part of the community that just wants to do object-oriented programming with Scala with a little bit of functional sprinkled in, and they don't care about any of that stuff. And there's a very distinct split. And so if you want to figure out how to do something because you're learning the language, or maybe it's a massive language, so you're going to always be learning. Well, you may see two vastly different approaches to the problem, and it may not be clear which one you need to take and why. And it can also lead to big splits in larger code bases as well, because you may have one team that prefers one style and the other team that prefers the other, and it kind of bifurcates the system that you're working in, and that can be a big burden. And that's just not really that big of a problem in F#. I mean, like any programming language, you can abuse it to all hell, and you can just do all sorts of crazy stuff. But the fundamentals of F# programming are going to be common just about everywhere. Again, we don't do binary or source breaking changes. This is, if that exists, it's a bug or an accident or something. It's something that needs to be fixed. The new version of Scala that's coming out, I'm glad that they're doing it, but it's going to have source breaking changes. So I'm glad that they're upfront about it, but hey, that's something that we just don't do. And again, there's commercial tooling support from Microsoft and JetBrains. There actually is a JetBrains Scala plugin. It's actually pretty good. I recommend trying it out. Don't let this discourage you from trying this language. Try out everything that I showed here. And then again, we do transparent and open evolution of the language. So this has also been a complaint that I've seen, which is that there's this ivory tower in which something gets innovated, and then it gets thrown over, and then the community kind of does what they can with it. And so as a result, they've built some incredible libraries that transform the way that you program in Scala, but that has been done somewhat in response to the language not evolving the way that they wanted it to evolve. And that's formed its own community and then its own split in the ecosystem. That's just not something that we have in F#, and that's something that we want to avoid because we want to be transparent and open about everything that we do, and we want to do everything to a point where not everybody's going to agree with how we move, how F#, the language moves and what we do with it, but we at least want there to be a reasonable compromise for everyone so that they say, yeah, okay, this wasn't exactly what I wanted, but I can still work with this. That is our goal, and that's what we seek to do. So kind of just F# versus X. I mean, there's lots of different languages. I don't have enough time to talk about every single one. We have our own guiding principles and our own approach to things, and they're fundamentally different from other languages. And that may appeal to you, right? We're not universally better than any language, and we're not universally worse than any language. We just have our own way of doing stuff, and that's just something that hopefully it appeals to you if you try it out. It's pretty damn great if you do, though. Most people who try F# usually end up really loving it. So one thing that I want to leave you with, if you try F#, you decide you like it, but you're like, oh, geez, how do I get this into the workplace? Well, here's your elevator pitch for your boss. You can tell them that Microsoft told you this. The first point is F# is a stable, consistent, powerful, and commercially supported language, right? Those are some checkboxes that business people like to see. So you can have that there. It has ubiquitous and featureful tools, right? You may have a developer on your team who doesn't want to use Windows and Visual Studio, and that's totally fine. There's nothing preventing them from using F# with the same solution that you are if you're using Windows and Visual Studio. You can work together, and there's not going to be a big issue there. All right? F# is a part of .NET and Azure, and it helps drive their innovation through a lot of different ways. And this is just it, right? And then F# has a healthy and active open source community. This is, I think, something that's increasingly important for choosing tech stacks in the future, because you want to have, say you have a particular tooling vendor or library vendor or something like that, and they don't quite do what you need at the time, you can find an open source library that does what you need. And maybe it doesn't quite do everything, and you can contribute back and things like that. That's something that we have in F#, and that's something that's really important. So, I think I'm going to leave you with that. Hopefully, this was a convincing enough talk to go try out F# on your own. And if you've tried it out before, but you said, oh, I don't know if I could get it to work in my environment or something like that, give it a go again. You have your elevator pitch for your boss to convince them that F# is worth it, because that's usually the number one problem that people have, actually. It's that they try it, they love it, but then they can't convince their boss who's doesn't want to see change in the code base for some reason or something like that. Well, this is something you can do. Thank you very much for your time, and